So now we've investigated some inverse functions or periodic functions. Let's have a look at some examples of how we might apply the knowledge we've just gained. So there's 4 examples here. I've chosen sine for all 4 examples, but you can apply the same principles and concepts to cosine and tangent, just remembering the slight change in the domain and range for the cosine function, and then again the change in the domain and range for the tangent function. But for sine, we're very familiar with the minus pi to 2 to pi on 2 and so forth. So what we're going to do is look at each of these examples in turn. So let's first of all look at the first one. So we've got calculate sine minus 1 of 2. So the first thing we're going to do is make it into an equation. So we're going to call it x equals sine to the minus 1 of 2. And then let's rearrange that so that we've now got the function 2 is equal to sine of x. Now, we're already very familiar with this concept. Now, we already know that the range of sine x is minus 1 to 1, and 2 falls outside of that range. So therefore, there is no solution. And we know this already from when we try and do that on our calculators. You can't do it because it's between the range is not between 1 and 1, negative 1 and 1, so there is no solution. So that's what we write. There's no solution, or it doesn't exist, or something like that. Okay, let's try number 2. Question number 2 is sine minus 1 over root 3 on 2. So again, let's make that into an equation. So we're letting it equal to x. So rearranging it, so we've got root 3 over 2 is equal to sine of x. Okay, so we've put it back into that form. Okay, so there's our equivalent statement. That's all fine. So then we say, right, well, how can we solve that? Well, can we solve that? Is there a value for x that will give me the sine of it to give me root 3 on 2? And we know that that's the case. Okay, we have our 1 root 3 to triangle. And we know that we have that right there, and the sine is opposite over hypotenuse. Then we are okay with the idea that the sine of pi on 3 is root 3 on 2. Okay, pardon me. So moving back to our final solution, the sine minus 1 of root 3 on 2 is pi on 3. Okay, is that okay? Is that within our domain for the function? Minus pi on 2 to pi on 2? Yes, it is. So there's my solution. Okay, let's look at question number 3. So we've got the sine of minus 1 of a third. Pardon me. Well, okay, that's a bit more complicated. We're going to discover a really nice relationship in a second, but let's do the math before it. So first thing we're going to do, pardon me, is we're going to say, okay, well, let x equal sine minus 1 of a third. So we're going to let x be the bit inside the bracket. So just like we've done in the previous examples, sine x is equal to a third. Okay, well, sine x is equal to a third. All right. Pardon me. Then we're going to substitute that. Okay, so we've got that problem there. So we know that problem there. So we're going to go, so if we think about, we're going to substitute this. Okay, is this here? Okay, so we've actually said that the sine of x, okay, so we've got the situation, we've got sine minus 1 of a third is equal to the sine of x. Okay, now just follow that flow in. So looking at the original function, so sine minus 1 of a third, we've said let that equal x. So I've replaced what's inside the brackets with x. Okay, and we also have the situation where the sine of x is equal to a third. So that must be equal to 1/3. Okay, so there's our solution. Now, what do you notice has happened? Well, we already know that the inverse function and the original function cancel each other out. So that's what we've discovered. And that's what we've proven by doing some tricky little algebra steps. Okay, so the sine of the sine of -1/3 is 1/3. Okay, so is it always just that simple? Well, let's look at question number 4. So just go back up. So sine -1 of the sine of 13 pi and 12. Okay, so we've got the sine of -1 of the sine of 13 pi on 12. Okay, so first thing we do, excuse me, is make that into a statement. So let's call that, so we're going to have x is equal to sine -1 sine 13 pi on 12. Excuse me. So moving the sine to the other side, we're going to have sine x is equal to sine 13 pi on 12. Okay, now, but it appears to have got the sine on both sides, so therefore x should be 13 pi on 12. However, we know that our domain has to be between -pi on 2 and pi on 2. So where's 13 pi on 12? Well, if we draw our rule, 13 pi on 12 is actually down here in quadrant 3. So we've got, it's down here. Okay, so 13 pi on 12. So what is the equivalent angle in the first two quadrants? Well, if we think about our cast rule, in the fourth quadrant, 13 pi on 12 for sine will be negative. So where is sine negative in the first two quadrants in our allowed domain? In this domain here? Well, it's going to be down here. Okay, and what's the equivalent angle in here? Well, it's going to be -pi on 12. Okay, so therefore, pardon me, sine of x is going to be equal to the sine of -pi on 12. Okay, so just repeating that, 13 pi on 12 is in the fourth quadrant. In the fourth quadrant, sine is negative. We can only have values that are in the first, or the third quadrant. I keep saying the fourth quadrant, my apologies. In the third quadrant, okay, 1, 2, 3, 4. So in the third quadrant, sine is negative in the T. So we can only allow to have values that are in the first or the fourth quadrant between -pi on 2 and pi on 2. So where is the equivalent? Well, it's over here, -pi on 12. So therefore, if sine x is equal to sine of -pi on 12, then the whole thing, sine -1 of sine 13 pi on 12 must be equal to -pi on 12. And there's our solution.